Hello everyone, I'm Nicola Di Santo and with this presentation I'm going to show a project made by Giovanni Buono, me, and Camilla Gironi as a product design advisor to transform the Sapienza Museum into a smart museum. After our first delivery presentation, we collected some comment and we did good on the choice of a specific target, but then our idea was too straightforward and not related to the IoT field. We also used a very common technology among our project, that is the Bluetooth Low Energy, and we did not investigate enough the environmental monitoring. So we have decided to make a pivot and to focus our project on the indoor microclimate monitoring for artwork preservation. Our new goal is the artwork preservation by indoor microclimate monitoring. We try to achieve the goal without consuming too much energy so that the project is sustainable. With this storyboard, we illustrate the new functionalities of our project. We see Gabriella that installs some sensor for indoor environmental monitoring inside the museum to preserve the museum assets, and with a web dashboard she can monitor the condition inside the museum. Some actuators also allow to maintain the value within a range, but if some strange error happens, the console will alert Gabriella and she can switch to real-time monitoring to have a better analysis of what is happening inside the museum. The architecture does not change very much from our first proposal. We have a set of environmental sensors. There are one in each room, and each sensor will interact with a LoRa board. The LoRa board will send through LoRaWAN the measured value to the Things network, and the Things network will deliver through MQTT those measurements to our middleware. The LoRa boards should ideally also be connected to some actuators. Those actuators will be in charge of maintain the temperature inside the museum within some threshold, so that the environment will remain safe for the artworks. If this is not happening, our LoRa board will transmit values that are greater than the threshold, and hence we will prompt a error message on the museum dashboard, and the curator can switch to MQTT to analyze data in real time, no more aggregated, and to understand what is happening inside the museum. It can either be a fault of the sensor or something is going wrong. Then our middleware basically, after interacting with the broker, will only implement persistence and is a transparent layer for the dashboard to get all the data it needs. Here I'm going to show a demo of our dashboard. So basically the dashboard on the main page will report among all the rooms. Then we can have a more specific view for each room, and if required we can switch to real time and analyze data as they come. To evaluate the project, we have implemented competitor analysis, some user experience evaluation, we have evaluated the required hardware and the overall cost of the system. From a competitor analysis, it emerged that some research group was focused on the preservation of cultural heritage, but what happened is that those projects are very old. Some of them does not even have remote monitoring, and indeed sometimes they just save data on a simple Excel spreadsheet and then they analyze them manually after. Due to this difficult period, we could not meet personally the museum curator and make them try our prototype and give us a feedback. So we have decided to make him try to some volunteer, and we use the think aloud approach as an evaluation metric. So basically, the prototype was given to those volunteers, and they just talk aloud, saying what they are trying to do, if they could, and if not, why. And the result was that the prototype seemed to be very intuitive and easy to use. For this project, we only require a generic STM Nucleo board, but this board must have Wi-Fi support so that we can use the MQTT protocol, and it should also have the possibility to integrate a LoRa extension board to work properly. We require one of each board inside the room at the museum, but indeed we might also think to use a single board for two different rooms. For a comparison of the cost of the major cloud provider, we have used the calculator available on their websites, and it emerged that the best solution to host our application is the AWS EC2 containers. We have done a quick estimation of our data volume. We have seen that our data volume is very low since we send aggregated data using LoRa, and then we require very few megabytes per month for storage. The Things network is free to use, and we have not considered the cost of AWS IoT broker for MQTT service. This is because we hope that we will use very rarely our real-time feature. As soon as the project will be complete, we would like to evaluate some additional feature. In particular, we would like to evaluate how much time we need from when we issue the command switch to real time to when it actually became real time. We would like to analyze the latency of the system. In particular, we would like to send messages only when required, even if in real-time mode. For example, if we sample data at 50 Hz, we will not send 15 messages within a second, but if the latency is, for example, 2 seconds, we will make a list of all those measurements, and we will only send one message each 2 seconds, because otherwise it is useless to send a lot of messages and overload our little board. Then we want to flash the code on a real board and try to perform some benchmark on energy consumption. Then we would like to adjust the message transmission rate based on the network latency. Thank you for the attention.